What is the significance of artificial intelligence and machine learning in reshaping industries through the integration of smart technologies? Specifically, what is the critical role of predictive maintenance? Should one entrust the organization solely to algorithms? Our next speaker will take us through the importance of predictive maintenance in AI-driven smart industry transformation. Mr. Ojenge Winston is not just a leading figure in the field of artificial intelligence, machine learning, and robotics. He is a visionary educator and practitioner dedicated to shaping the future of technology in Africa and beyond. His role as the head of the Digital Economy Program at the Africa Center for Technology Study and as a lecturer at the Technical University of Kenya speaks volumes about his commitment to advancing knowledge and fostering innovation. Kindly join us in welcoming Mr. Ojenge Winston.
Thank you very much, audience. I'm pleased to be your speaker today over the benefits of smart technologies in manufacturing. I'm Dr. Ojenge Winston. My background is in computer science and digital technologies. Welcome. So the hot topic today is resilience or relaunch. Is manufacturing at a crossroad? Wisdom would say that we go towards resilience because relaunch has its costs, and you're also bound to lose your market niche as you stop operation and then relaunching afresh. Disruptions are going to be out of the day. They're probably going to intensify as the years roll. And you can see clearly agricultural products, chemicals, manufacturing, metal, oil and gas are some of products that are now getting in short supply. And yet these are the basic components of most manufacturing processes. You expect disruptions out of COVID-19, US recession in the offing, the later part of this year or early part of next year. So it's upon every manufacturing entity to ready itself for resilience. What is the solution to ensure that even within disruption, you're still able to have your operations move on? A lot of times we do firefighting. It has its advantages, of course, because you have to survive at all costs in order to fight another day. But a better solution would be to build a nerve center. A nerve center basically would be an infrastructure that involves people, a certain type of people who always are pessimistic and think that there's going to be disruption tomorrow, so they prep for it. An operating culture, digital twin. You need to be able to use these tools to simulate and plan for disruptive scenarios so that then you can engage your decision-enabling tools. Related to building a nerve center, of course, is exploiting the existing ERP platforms in order to exploit all that data that is coming from your enterprise value chain and use of AI, machine learning within a platform of Industry 4.0. I'd like to invite you to look at this, which for me is everything. It's what you'd call gospel. All enterprise value chains or manufacturing enterprise value chain would have this set of steps. So you'll have a supplier. You probably have a chain of suppliers or a set of them. You'll have logistics. Those are routes of freighting raw materials onto your store. From your store, you introduce your raw materials onto your manufacturing plant or the floor. And the floor has several processes. Now, these processes, of course, are what converts input to output. And there would be several of them. You enter raw materials in process one as inputs, and they come out as output And that output of process 1, chances are that become input for process 2. And the chain continues. But you can see that at this particular point, the process is being automated. It's being controlled by a remote terminal unit, which is basically a processor. So the processor will get to know what is in process 1 through sensors. So the sensors measure some of those variables that are important to you in process 1. Could be temperature, could be pressure, could be level of liquid within a tank. So within the processor, that is the RTU, it has a control program which has the desired value for, say, temperature that you want in process 1. So it comes through the sensor. The RTU looks at the actual value which has come from the sensor, maybe the actual temperature, and compares against the desired temperature, which is within the control program of the RTU. And if there is deviation between the actual temperature and, say, the desired temperature, then the RTU will instruct the actuator, which probably is a heater, to be able to heat the process to the desired temperature. And this continues around all the other processes. But of course, up here, you can see there is the supervisory unit, which is a bigger processor, which has a bird's view of all the processes and all the RTUs across the manufacturing plant, so that it's able to tell which RTU affects which other, in what way, and be able then to organize all the RTUs. Then at the end of the manufacturing stage, which is the manufacturing value chain, then we have products which come out. You will conduct quality assurance on them. Then you take them to the storage. Then you take them to the market. And then you conduct accounts to tell whether you made profits or you're losing. Now, out of that flow, there are other 4 very important components, like human resource, which are really not part of the sequence. But human resources are engaged almost at all stages of the chain. You have utilities like energy, water. You have security, could be physical security, could be cyber security. Then one other thing which is emerging is responsible AI. You will have to find how to evaluate how AI or all these smart technologies are affecting human rights for stakeholders within the organization. So all these data then are supposed to all be collected at a cloud where there's a database, huge database. And from this database, then the machine learning or AI and analytics can get access to this data and be able to crunch it and tell you trends. Be able to relate to you how supplier is, for instance, affecting quality assurance, how logistics is affecting marketing, how manufacturing variable is affecting quality, etc. So this particular infrastructure, most ERPs, initially ERPs were basically platforms that would collect data around the business component, like the supplier, logistics, store. And then they would sleep during manufacturing, they go to sleep, then they wake up at quality assurance and go on up to accounts. But currently we have ERPs that are able now to leverage data and are able also to monitor what happens on the manufacturing floor. And so therefore, Industry 4.0 can easily be implemented by some of the most modern ERPs as we know them. Look, this is very important, and I think your success as a manufacturer, if you want resilience, if you want to model so that you're able to predict what happens to your enterprise tomorrow, is to know how to pick the right data. You need to pick data for all factors of production that ever affect your production, and you must agree that supplier definitely is one of them. So the supply identity, because there would be several suppliers, but remember, every supplier will have their advantages and disadvantages. So you have to keep supply identity, the country the supply is coming from, the stability of politics of that country, because remember, you're watching out for disruption. The length of experience, supply stability, prices by that supplier, stability of that supplier, mode of payment, to say. At supply logistics, you will have also to collect probably data around the medium of freighting. Is it shipping, air, trucking? Oil prices, how are they moving currently? The length of supply routes, security of sea routes, stability level of countries, of ports through which your supply goes through. You also need to collect data around the raw material storage, the capacity, regular quantity, preservability of raw materials, its proximity to manufacturing plants, storage quality, ventilation, all that stuff. Because all these things I'm talking about are actually influencing the quality of your product. Remember, as a manufacturer, yes, what are your goals? Our goals are quality assurance or quality of your products in the fastest way, processed in the fastest way, and processed as cheaply as possible in terms of human resource, cheap raw materials, cheap water, power, cheap space, in order for you to increase your margins. When you come to the manufacturing, there are also data that will have to be collected 24/7, process desired values like the desired temperature for each process, the desired pressure for each etc. The controller settings, the processor has settings. The sensitivity, stability of the process, the rate of correction, all these are very important because they tell you, actually this data would be used to be able to tell whether your machinery is breaking down or part of your equipment are breaking down. And this is where predictive maintenance comes in. Because sensitivity of your process, of your control system, the stability and the rate of correction, you will have to identify some threshold values for this so that you have a computer program that is just monitoring these values so that when they touch a certain level, then those are warning signals that a part of your machinery is starting to shut. You also collect that around quality assurance, the quality of each product cohort, because you see products will have cohorts and quality between cohorts may vary. And this could be related to your supplier. Remember the data you collected about the type of supplier and the routes the suppliers were taking, and also the manufacturing plant. So you need also to keep a tab on, keep tracking the quality of each cohort of products that comes out. Maybe even the standard deviation of the quality of each cohort, the reject ratio of each cohort, you can relate them to the other variables we talked about. Product storage, you collect data. Marketing, what is the speed of sales? What is the customer satisfaction rate? You have to keep monitoring your customers. They tell you, they would be able then to qualify the quality assurance you had measured in the first place. Market analysis levels, all these are data you need to collect about marketing. Accounts, profit, loss, etc. Human resource. You will be surprised that a particular worker, when they come on board in their shift, quality goes up or quality goes down. How will you tell this? Through also keeping data about all your workers. What is every worker ID, the level of education, level of training, grade, experience in years, where training was done, at what point did they come on duty, what is their gender, what is their age, etc. You probably would then realize that certain jobs, certain qualities are easy to maintain with certain genders, etc. Security, what type of attack did you have, whether physical, cyber, gender of victim, age of victim, etc. And utilities, how much energy did you use at any one time? At what process? During what cohort? Did you use what quantity of water? This should help. Then finally, or not finally exactly, you need to keep a track of responsible AI or pixel AI. What effect is it having on the human rights of your workers? Who is losing jobs? Who is gaining jobs from AI, from the automation that you brought into, or smartness you brought into your business enterprise? How transparent and explainable are some of these predictive models that have been built at the machine level, machine learning level? They need to be able to explain themselves why they probably predict this and not this. Data protection, you need to evaluate. The gender equality and inclusivity levels of some of these models, the precision, accuracy of the models, you need to keep monitoring the predictive accuracy of the models. And one very big thing is the carbon footprint of each model. These AI models, during their training and their engagement, they consume so much energy, and you need to keep track of which particular platform. Is it by Google? Is it the one by Amazon that seems to be consuming most energy, so that then you identify algorithms which are conservative than others. As I finish, there's some benefits of Industry 4.0 which we need to be able to distill, illuminating how each factor of production relates with the other. This is very important. Those predictive models are relating every part of the production process to the other, so that you know what affects what. Then you know how to control each one of them. There's also enterprise simulation. You can now plan for disruptions, and you can optimize factors of production using what-if models. You can precisely automate the process control, so that those process variables like temperature, like speed of motor, like pressure, level of liquid, you're able to control them more precisely. And you can now conduct predictive maintenance. You're able to tell months away whether one particular equipment is starting to have trouble through the data from its operations. So these are just examples of some of the ERP come Industry 4.0 platforms. They're actually ERP platforms, but they have plugins for Industry 4.0, which basically means collecting data from every point of all the three main chains, value chains. That is the supply value chain, the manufacturing value chain, and then the marketing value chain. Then you'll be able to understand or build very precise models of your business enterprise. Thank you for listening. Great.
Welcome to the Smart Industry Forum, where we discuss the latest tech developments and their impact on manufacturing and supply chain sectors in Africa. The forum will feature discussions on Industry 4.0 technologies in manufacturing, logistics, supply chain management, efficiency and productivity in smart factories, cybersecurity, and global trade impacts. Join us as we delve deeper into the industry world.